I'm actually starting. Stand to the side. Can we go? Are we starting? We're good to go? Okay. Amazing. Hello, good evening, everyone. Please take your seats. We're about to begin. Okay. Good evening, everyone, and welcome to the MIT 100K launch. I'm Celine, and I'm one of the managing directors for this year's MIT 100K, and I'm joined with Taylor and Jayshree, my other co-directors. We're really excited to have you join us today, both people in person as well as everyone who's joining us virtually. For those of you who aren't familiar, the MIT 100K competition started over 30 years ago when a group of students teamed up with MIT professor Ed Roberts to bring the school's motto to life, Mens and Manus, through a startup competition. With Ed's help, they raised $10,000, just enough of a spark for the entrepreneurial movement that became the 100K. It's only grown since, going first from 10K to 50K to now the 100K that we know. This competition, though, isn't just about this one big night. It's a year-long journey for our competitor and for the students. It kicks off with pitch in December, goes to accelerate in March, and finally culminates in launch happening today, where finalists will compete for $100,000.
Of course, this is all made possible by our incredible sponsors. First up, I would like to thank Akamai, our presenting sponsor. For those of you who don't know, Akamai competed in the 1998 competition of the 100K. It is one of our greatest success stories. Thank you for paying this success forward to enable young entrepreneurs to achieve their dreams. For our next sponsor, we'd like to thank our newest sponsor, Goodwin, for sponsoring this year's competition and sponsoring Accelerate competition and sponsoring us throughout the entirety of our life cycle. Headquartered in Boston, Goodwin is a leading global law firm with deep expertise across innovation, entrepreneurship, and the whole ecosystem. The firm partners with founders, investors, and high-growth companies at every stage of the journey, and its commitment to supporting emerging ventures makes Goodwin a natural fit for this competition. And lastly, we'd like to have finally a heartfelt thank you to the Morgenthaler Foundation. In honor of the late David Morgenthaler, an MIT alum and a true champion of entrepreneurship, we've not only sustained but increased their sponsorship this year, deepening their impact on the MIT startup ecosystem. The funding all sponsors and partners have provided us enabled us to have this competition today and provide the prize money for the MIT 100K. In addition to their support, our partners also serve as mentors and guides for our teams and for our organizing committees.
And of course, this competition is made possible by our preliminary round of online judges, spanning multiple industries and geographies, who volunteered their time reviewing applications and providing crucial feedback to ensure the competition's fairness. We'd also like to thank our semifinals judges who selected the teams that will be competing tonight. And now to introduce the judges on the panel tonight. First up, we have Boaz Vackler. Boaz is a partner at Link Ventures, where he invests in AI-first companies out of MIT. He invests in companies out of MIT and Harvard ecosystems. He has led investments in unicorns like Blitzy and Aru and is a former founder and an MIT Sloan alum. He works hands-on with founders on everything from product to strategy to fundraising. Thank you so much for joining us tonight. Next, we have Parker McKee. Parker is a partner at Pillar VC, where he has spent the last decade investing in next-generation networks. He also focuses on AI-powered applications and software infrastructure. He is a veteran of the Boston venture scene, and he supports a diverse portfolio of companies, including Adaptillions, Reclaim, and Open Hands. We are also thrilled to have Robin Chase, a pioneering transportation entrepreneur and the co-founder and former CEO of Zipcar. She also co-founded Venium and Numo, focusing on sustainable urban mobility, and is the author of Peers, Inc. She's a graduate of Wellesley College and an MIT Sloan alum. Robin has been recognized on the Time 100 list and currently chairs the board at Tacows. And finally, we have James Champ. James is the co-founder and partner at Bloomberg Beta, where he focuses on seed stage investments and in the future of work and AI foundation models. With a background as a software developer and experience at Bessemer and BCG, he has backed industry leaders such as LinkedIn, Weight and Biases, and Streamlit. Thank you so much for joining us, and we look forward to your insights tonight.
We also want to have a sincerely thank you for everyone on the MIT 100K organizing committee. Our team has invested countless hours to ensure that the 100K is the success that it is today. And without them, none of this would be possible. We also want to recognize our audio and visual production team here at MIT, which have been helpful in enabling this hybrid event. Please give us a round of applause for our team. So now let's get to the main event. In April, over 80 teams applied to compete to tonight's event, and our network of external judges reviewed each and every application in the preliminary round. Out of those 80, 16 teams were selected to compete in the semifinals at the end of April, and out of those 16 teams, 7 teams were selected today to advance to tonight's final event. This evening, these teams will compete for a grand prize of, you guessed it, $100,000. The second place prize will be $50,000, and the third place prize and audience choice award of $5K each. In terms of today, we'll start off with 5-minute pitches from all of our 7 teams that you see on the slide, and they'll give you an overview of their exciting ventures that they're working on. Each finalist will then take about 3 to 5 minutes of questioning from the judging team and deep dive into their ideas. Once you've heard from the teams, you can vote to determine who will win the $5,000K of the Audience Choice Awards in the audience by using the voting card you receive when you arrive, as well as the QR code that's going to be on the screen momentarily. To all of our competitors tonight, we wish you the best of luck. Let's get to the pitches.
First pitch of the night comes from Pixology. Pixology is an agentic AI platform that creates on-brand, sponsor-ready sports content instantly, turning live moments into monetizable digital assets. Welcome to Pixology.
Imagine the craziest sports moment you can think of. The crowd's going wild, the internet's blowing up with fan engagement. Recently in March, when you
run through the ball,
might be one of these moments.
Get it into Boozer, back for Saar, ahead, Boozer, that ball deflected and stolen by Mullins. Caravan, 2 seconds, Mullins tosses it up. Oh!
This was Braylon Mullins' most valuable moment of the season. It generated over millions of views and is only relevant for a very short window of time. However, behind the scenes, there's a huge problem. This moment went completely unmonetized because the business of sports is moving in slow motion. It takes days to manually design and create content to capture this moment, and then weeks to sponsor this moment using an antiquated email sales team process. This is why we built Pixology, where we monetize the moment while it's still alive. Our agentic engine can detect these viral moments, deploy agents to negotiate with various brand-side agents to find the optimal deal, like this one with Rolex. Our engine will then instantaneously generate on-brand campaigns, like Precision Under Pressure, which both matches the Rolex brand and the buzzer beater moment itself. And throughout the entire deal cycle, we can comply with a very messy regulatory landscape and ultimately deliver this content across any medium. So welcome to the future, where Rolex could have deployed this moment instantaneously inside the stadium on the Jumbotron and to their social media account to capitalize on this moment. And Braylon Mullins himself could have received a check to his phone before he even reached the locker room. We are the team to solve this problem. We're a team led by ex-professional athletes and AI ML engineers from IIT and MIT. All three of us are MIT Sloan Fellow MBA students who are serial entrepreneurs with a track record of success. All three of us have turned down lucrative job offers to be 100% all in on this project. And we were joined by world-class advisors, including ESPN's first social media director, Ben Shields, and Colette Watson, president of Rogers Sports and Media, who recently renegotiated the NHL's $12 billion media rights deal. We completed the entire ecosystem of MIT Entrepreneurship, and after completing MIT Fuse this year, we launched the first beta version of our product just this past February, and since then have received 10+ paid pilots we've closed on across our beachhead market of NCAA athletics. And we've also received enterprise validation from pro teams, leagues, and broadcasters, and recently, as this morning, just signed a new partnership with Unrivaled Basketball, securing 12 more teams. Parker, we do apologize for having an Ohio State logo up here. We know you're a Michigan alum. They are next on our list, and we're hoping you can help us close them. What's most exciting here, though, to us is our customer usage statistics. We have offloaded over 50+ sponsorship deck graphics for our customers, and in our first 6 weeks have published over 100 assets across various mediums. And each team is averaging over 4 hours a day on our platform. This is the exact moment to capitalize on this opportunity. The NIL and sports sponsorship market are booming. And essentially, the NIL market is expected to double again by 2030, both experiencing double-digit CAGRs. And when landmark legislation came out in 2021, each athlete became a media channel. And now AI has finally enabled that scalability, where custom AI models can preserve full-body athlete identity and equipment to capture them in images without ever needing them to shoot.
This is our platform, the agentic OS for sponsorship economy. 3 jobs, 1 platform, end-to-end. We create the pitch, we capture the deal, and we deliver activations. Our defensibility is in the bottom 2 layers. The agentic layer, where we have specialized agents which deal across every stage of the deal, of the 6-stage deal here, and they share context to ensure that they are efficiently executed across. And the important context layer below that is where we have our fine-tuned LoRa models and data graphs, which are driving the whole ecosystem. So most of the context layer which we have trained, the LoRa models what we have trained are custom models for each customer, which are trained on their brand libraries, their athletes, and their venues. And these are always ensuring that every output that generates from the platform is brand aligned by design. And we are deeply integrated into the CRM ecosystem and the inventory databases of our customers, which is giving us more stickiness to us and also eventually creating a data moat to us. Today, we own the creatives, and tomorrow we are intending to own the deal.
When used correctly, Pixology becomes one of the most powerful tools for driving partnerships and revenue at Rutgers Athletics. Thank you. We can hear you.
I'll talk loud. First off, great job. Not sure if I can help with Michigan, but I'll do whatever I can. I'm most curious about the stakeholders here. So there's a bunch of different players. There's the athlete themselves. There's the person that owns the content. There's the university. There's the potential advertiser. Who's cutting this deal each time on the fly? And is it pre-negotiated? Is it something you have to work out each time? What have you seen thus far?
So it's one of the reasons we're working on our beachhead market of NCAA athletics. There's been a lot of clarity to the space recently in terms of exactly how, when a team uses an athlete, what type of licensing arrangement should be in place, and when an athlete brings a deal, if they're using a team logo, what that licensing looks like. So right now, we're really selling to the teams in our creative, and then we're moving towards being able to eventually then take a platform fee from the brands, but we're really focused on that team itself right now. We also view agencies as our customer, where we're not disrupting the existing agency ecosystem. We sell to the agent, let them negotiate directly with the athlete.
Is there any standard deal, or is it all different?
Pardon me?
No standard deal in place, though.
No, so there'd be no standard deal. It'd be deal to deal, athlete to athlete, just because each athlete's NIL has a different value based off their follower count and their position and value.
And so are you relying on the brands to have their own agents to negotiate on their behalf, or are you doing something for them?
Could you repeat that again?
Are you relying on the brands to negotiate on their own behalf, or are you building something for them?
So right now, our platform, this is a two-sided platform with brands and athletes. So we're starting with the colleges and athletic environment, where we are trying to own the one side of the platform first, eventually getting to the brand side of it. Right now, these people, the college athletes already reach out to brands. We are starting where the customers are, and then eventually kind of making the two-sided platform.
We are certainly laying the groundwork for this, though. Green Bay already has over 500 sponsors onloaded to our platform, and we are APIing in with the Salesforce CRMs of our customers, so we're already knowing who's working with what, how much they're paying for X deal, what deal closed, what didn't, to lay the groundwork for the brand side recommendations.
I would like to add with Robin's book here, which is Peers Inc. We see a place where every unsold inventory which is there in the athletic departments, we see a world, we create an Inc. platform where we distribute these assets and create more discoverability for brands. And that is what we eventually want to do.
Go ahead, Robin.
You talked about your pilot and you had some statistics that you gave. How do those compare with what happens today? And how long does it take to close that deal? I mean, if something's happening so fast and you've got to do it, like, how does that happen?
Yeah, so right now, essentially with our pilot customers, we are sorry, or actually you take it if you want. Go ahead.
So in the current ecosystem, the next one. Yeah. In the current ecosystem, the clients are using like 6 different applications to run one sponsorship deal. One is to create something like Adobe or Greenfly. There are different applications for legal compliance. So there are like 6 different tools that they're using to just close one deal. And which is where we come in, and we're trying to expand that and make this seamless.
And so right now, it's really manual. We're manually designing these tools. They take days to create. So one sponsorship deck might take a week to create right now manually, and need to go through multiple different approval layers. And these are entirely hypothetical graphics that need to be created very quickly. So we essentially bring weeks to days or minutes.
Does the content owner or the person that previously bought the rights to the stream, do they want you guys to exist, or is there an adversarial relationship there? Are they thinking they should do this in-house, they can do it better, they probably can't do it better, but...
Yeah, from all our PMR, this is a win-win across the ecosystem. Agents hate dealing with getting their athletes to these things to be able to go shoot. Players hate taking time out of their already busy practice and training schedule to do something that is not their day job to go shoot this content. And teams are really constrained on the back end and their back office on what they can create, spread across multiple teams. Right now, Rutgers, for example, is using 3 separate graphics teams to create this content.
But I guess like let's use the Big Ten Network, for example. Like they own the content. They'll sell it off to Disney or some other streaming, ABC, some other streaming platform. Do you need to get approval from them to use it, or is there some license that if it's below 30 seconds or 10 seconds, you have the right to disseminate it without a
No, because we're selling the athlete likeness, right? So we would generate, moment happens, we would generate our own custom content with the athlete, celebrate a moment that they already own. So there's no licensing here. We're not embedded in the broadcast ecosystem. It's AI gen.
Yeah, my only encouragement to you would be to think about this as a media format rather than thinking about this as an advertising tool, in part because you'll just get captured by the big sports teams, which will be a big waste of time. Does that make sense? Could you?
We're having difficulty hearing, sorry.
You don't want to think about this as just an ad format. You want to think about this as actually a new media format, because that's probably the only way they'll break through the noise. Because otherwise, you're going to have to do what they all tell you to do rather than create something genuinely new. Does that make sense?
Yeah. Yes, absolutely. And we view this as what we call micro sponsorships.
Thank you so much.
Thank you.
All right. Thank you. Okay, that's good to know. Okay, thank you so much. Next up, we have NeuralPhysics, who is building foundation physics model and agents for hardware design, simulation, and manufacturing. The clicker's on the podium. Clicker's on the podium. Yeah.
Hey everyone, we are NeuralPhysics, and we are building AI that lets engineers design 1,000 times faster. This is our team. I am Mo. I'm a Mickey PhD student here at MIT working on the intersection of physics and large-scale simulations, with my co-founder Xian, who is a Mickey postdoc at MIT. We both bring industry experience, and we have been working on this project for more than 3 years. We have our amazing advisor, Professor Angela Dai, who leads the 3D AI lab at the Technical University of Munich. This is how we design things today. It's very slow and tedious. Designing a car can take 3 to 5 years. Designing an airplane can take 15 to 20 plus years. Without fast simulations for aerodynamics, structure, stability, control, everything is slow, expensive, and hard to predict. With NeuralPhysics, we are building foundation physics model for design and manufacturing. We are streamlining the whole design process to explore more ideas, reduce cost, and build with confidence. We built the first foundation physics model, trained on hundreds of terabytes of simulation data, and validated against real-world designs. We trained a large physics AI model that understands both the physics and the 3D geometry. As the outcome, 1,000 times faster and more than 99% accuracy. Our key differentiator is a fully automated pipeline for large-scale and high-fidelity dataset generation. This includes car aerodynamics, aerospace design, car crash simulations, and marine simulations. And we are currently working on extending our pipeline to include additive manufacturing, data center cooling, chip simulation, and wind and turbo machinery. We tested our foundation physics model with one of the leading car manufacturers just last week. We tested our model in a completely new design that's still under R&D and has not been released yet. We achieved 99% accuracy against their physical testing, which means 1,000 times faster in terms of design iterations. This is another example where we deployed our foundation physics model against state-of-the-art legacy software for crash simulation. You can see the results. This means we could reduce simulation time from hours to less than tenths of seconds. This means also that go-to-market can go from 3 to 5 years to less than a year. And companies could save hundreds of millions of dollars on each product they are designing. This is how we are disrupting the whole industry. We have two business models. The first is that real-time access to high-fidelity simulation data. And the second is access to pre-trained foundation physics model. You can train it directly on your own data. Last year, we were able to get more than 25 paid customers already, and a total of 240K in revenue. Our customers love our product. This includes NVIDIA, AWS, and all the simulation software companies, Ansys, Altair, Siemens, and Cadence. Car manufacturers also got our data set, like Toyota and Volkswagen. Even startups, PhysicsX, and Neural Concept. And this is what I mean by a fully automated pipeline for large-scale, high-fidelity simulations.
Testing new car designs used to take years and cost millions of dollars. But this new AI tool does it in seconds for a fraction of the cost. MIT engineers just created the largest database of car designs ever made public. They use generative AI to create and test 8,000 different vehicle designs. A powerful fluid dynamics simulator then tests how air moves around every curve and edge. The database is trained on detailed 3D models of 3 distinct body styles: fastback sedans, notchback coupes, and station wagons. Car companies can now use these designs to train their own AI systems, generating new vehicle concepts in seconds instead of months or years. Many people have range anxiety, the fear that their EV battery isn't sufficient for longer trips. But this database could accelerate the development of long-range batteries because of the ability to rapidly test the efficiency of different body shapes. Expect to see new cutting-edge designs in the coming years thanks to this trove of data.
We are NeuralPhysics, and we are building foundation physics model for design and manufacturing. Thank you very much.
Fantastic job. Trying to understand, is this going to be, you're starting from small foundation models or mini foundation models, and then you expect that to all aggregate and become one big foundation model? What's the kind of roadmap here?
Yeah, so that's a very good question. Right now, we focus on specific area. We start from the aerodynamic simulation for vehicle design, and then we expand it to car crash simulation because we use small model to test the customer feedback. Like if the customer really needs this type of model, and we already proved this from the aerodynamic safety simulation model. So, and then we just try to scale it up progressively to different areas and more broader domain.
And if I understand correctly, you kind of built this data simulation engine. Are you planning to be kind of a data simulation seller to others in the meanwhile and also sell the foundation model itself? Are you going to do RL environments of simulation? How are you planning to go to market?
So that's a very interesting question. Compared to large language models or vision language models where you have tons of internet data, for physics it's very difficult. You can also get some really nice, colorful results, but validating it against physical testing is the most challenging thing. I think this is what sets us apart compared to our competitors, is that we bring both the model, like we know how to train these models from scratch to respect the laws of physics, whether it's Navier-Stokes or any kind of structure equations. And we also have the data availability. We can scale data to different domains and different fields.
Last question, when would you have the fully kind of parallel to LLM foundation model ready?
So I think the maximum we have now is maybe 500 terabytes of simulation data. I think we are scaling to 10 and 20 times hopefully by next year. But again, that's why we need funding to scale our simulation pipeline and also scale the physics AI model.
Yeah, I think I can provide more information. So training a large language model, for example, GPT-3, so the data scale is around 20 terabyte data to 30 terabyte data. So you can easily get the data from the internet. But for us, right now, we only cover 4 areas, and the data set scale is 1 terabyte data. So that means developing foundation model for simulation, the data scale and the model scale is at different magnitude or different level to large language model. So it's harder, so we need bigger model and bigger data sets. So more effort on this.
Bigger budgets.
Thank you.
You talked in the beginning about both airplanes and cars, but it looks like from your experience you're focusing on cars. Oh,
Thank
quickly.
you.
Oh.
At time. Amazing. Amazing, thank you. Amazing. Next up, we have Mohan, the team who is using generative AI that models the subsurface in 3D, helping exploration companies drill fewer holes and find more ore.
All right, good evening. We are Mohan. We use AI to find copper. So why us? 3 things have to be true to win this. Best geology, best AI, and the best network. They almost never sit in one team, but they sit in ours. Best geology, Professor Olivia Yagutz, director of MIT Earth Resources Lab, and our chief scientist, co-founder trained under him. Best AI, Xing Jianbai, CSL PhD in generative model, the core methods behind our technology. Best network through MIT Mineral Stewardship Consortium, BHP, Vale, Rio Tinto, doors already open. And why this is so important right now? Because everyone is talking about AI, everyone is talking about chips, but nobody talks about what they all sit on. It's copper. Because every cable, every GPU, every data center, it's copper. It's all copper. And by 2030, 4 million tons of copper short, and we don't know where the next deposit is. We just drill and hope. So how do we find copper today? By drilling, but $500,000 per hole, 90% miss. It is brutal. Maybe the most expensive guessing game on Earth. So people tried using AI to improve the efficiency of drilling, but like cobalt metals, they model the Earth as 2D slices. Earth is not two-dimensional. So we built it, full 3D subsurface model by generative AI. How do we do it? By diffusion model, the same technology behind Sora and Midjourney. Look at this. Noise, structure, detail, puppy. Noise, structure, detail, Earth. The same mathematics, we just run it on the ground. Yeah, but here's a catch, because to train a model, we need data. Puppy images, it's free. But subsurface data, $500,000, the most expensive data humanity collects. Our answer is, we build by our own. We are compressing thousands of years of geology in silicon. And this process, from pristine Earth to thousands of different geological deformation to all realistic ore bodies, this process is reviewed by professional geologists and also patent pending. This is our biggest moat. So what do our clients get? It's a very straightforward process. They gave us one thing, the drill core data, and we gave them 3 things back: where the copper is, how certain we are, and where to drill next. One model, 3 answers, very straightforward, decision ready. How do we know it works? We tested against cobalt metals methods. Same data, same task, we are 30% better on average, and for the best cases, we are 2 times more accurate, or 60% fewer drills. Translate this into dollars, that means $30 million with the old way, and $21 million with cobalt metals, and also $50 million with us. And the market, copper alone, it's $3 billion. Everything about subsurface decision making is a $500 billion market. How do we make money? Very simple. We license 200K per target. We take the royalty up to 2% per discovery. That means one find up to $500 million in upside. And also, every project makes the next one smarter, so the moat can compound. And usually, the most difficult part for the deep tech company like us is how to get the first customer. But luckily, with MIT ERL, Madden, Freeport, with MIT MSc, BHP, Vale, Rio Tinto, we are not knocking the door. We are already inside. Here's where we are. The model is proved. The customers are lining up. Lab is done, and we need to get to the fields. That is exactly what 100K can unlock for us. The first paid pilots, the field validation, from MIT labs to a real copper mine. So nickel is there, copper is there, lithium is there. Every critical mineral we need is already there in the ground. We just cannot see it until now. We are Mohan. We see through the earth. Thanks.
Really good in lots of ways. Let me just ask this quick question around that 30% benchmark. Like, so how much better do you think it can get over time, or what do you think is the right way to expect how good it can get compared to the benchmark?
So our synthetic data, the validation page, can you pull that up? So 30% is based on 20 different test targets. So we build this test data of a real copper deposit, combining 174 copper deposit. And on average, we are 30% better. So it's calibrated by real data. Yeah.
What do I need to feed into the model to get an answer? Like, could I point this at the whole state of Wyoming, and just you'll tell me what acre to go buy? Or do I need to go seismically scan the acre and then hand you that data?
How much work do you have to do before you can decide to build the data? Can you just take satellite photos right now, or does it require much more work?
We can definitely include the satellite data and the geophysical data as the conditioning for the generative model. But for this one, our biggest mode is that we based on the physics, how magma flow, and how critical minerals formed, we build this data set. So basically what we need is the drill hole data, the chemical analysis, the lithology, and that's all. We can tell you where to drill next.
All right, the obvious question: why ever license it? Why not just go start a fund now? Can you guys hear me or no? Yeah. 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 Oh, there's echoes. Sorry. All right, no mic. That's better. All right, sorry. Why not raise a fund and just go buy a bunch of land with copper in it?
That's one option, and there are some companies in the field already doing it. But we are intentionally choosing another path, which is can be shown here. We are starting from the copper, but expanding to different other critical minerals, because our architecture are designed for that transferability. As long as that natural resources could be described in physics, we can expand to that. That is our venture scaling up plan for it. Like natural resources, geothermal, oil and gas, lithium, nickel, everything could be described in physics. We can model it. We are more excited by this scaling up plan. Yeah.
So I'll chime in again. Can you provide more clarity on what data feeds into this? It's a mix of satellite data, it sounds like?
The minimum data requirements is only the drill core data. And we have another input is our proprietary data, but that data set is aimed for teach the diffusion model what is a plausible ore body might look like encodes all the geological knowledge to the model so that it can imagine what is everything between the drill core. But what we need from the mining side, the minimal is the drill core data. Yeah.
Thank you so much.
Thanks.
Now let's welcome Iceberg Systems. Iceberg deploys societies of autonomous agents to predict cascading risks to human populations and infrastructure. Please give me a round of applause for Iceberg Systems.
Hello. Hello. Hi, I'm Ayush, co-founder of Iceberg Systems. Our platform simulates millions of AI agents to predict how risks cascade across the economy. As we speak, the US government uses Iceberg to monitor over $1 trillion of exposure across the economy. And in the next 5 minutes, I'll show you why every banker and insurer is about to need it to. To make this happen, our team brings together deep expertise in AI and financial risk. Ramesh and I built Iceberg over the last 5 years in our lab at MIT. I previously did risk intelligence at JP Morgan. Shantanu on our team was the chief technology officer at the NatWest Bank and is precisely the customer we're selling to. Vedika joins us from BCG and runs go-to-market at Iceberg. Meet Jack, one of our design partners. He runs a loan portfolio at Wells Fargo. And this morning, he has one question on his desk: whether to refinance a 30-year loan for a luxury clinic in Seattle or in Memphis. So Jack pulls up his tools, Moody's, Bloomberg, FactSet. They say Seattle, higher income, good credit, strong historical demand. However, the economy is changing faster than Moody's forecasts can anticipate. In Seattle, AI is eating into knowledge work that makes it possible to pay for luxury care. And in Memphis, reshoring is rebuilding the middle-class wages that can walk into clinics. Iceberg captures this forward-looking risk in the labor market across patient populations and helps Jack simulate how it may ripple into customer health, clinic revenue, and ultimately loan performance. Now, Jack's prior tools cannot anticipate this cascade because they model assets, but not the behaviors that connect them. A shock to labor doesn't just affect wages. It causes consumers to cut spending, reduces lease vacancy rates, and causes loans to deteriorate. And by the time this shows up in data, credit scores or vacancy rates, it's too late. Jack's loan is already underwater. So we built Iceberg to fill this gap and help Jack see the cascade before it shows up in data. Iceberg simulates behaviors across millions of market participants, from workers to consumers to institutions, to simulate and predict how shocks cascade through their interactions and create systemic risk in the economy. Here is a quick demo of the platform in action. So Jack starts using the Iceberg platform to measure risk at the state level. He can drill down to counties within the state, looking at exposure patterns at counties around the Seattle area. And then he can double-click into Jefferson County, where this particular clinic sits. Here in the Jefferson County, he can measure exposure across different patient populations, worker demographics, across diverse number of zip codes and geographical regions, and then simulate how this exposure spills into credit vacancy rates and Jack's loan book. The Iceberg platform allows Jack to run millions of such risk scenarios to stress test risk on his portfolio before it shows up in actual data. To make this possible, we invented an entirely new class of AI systems in our lab at MIT. These are called large population models. So instead of having one AI make predictions, LPMs coordinate millions of AIs that work together to simulate how risks emerge from interaction. Together with the DOE, we worked to deploy LPMs to model a digital US, where 300 million AI agents work together to monitor risks across multiple sectors of our economy. And it's already protecting each one of us. Over the last year, Iceberg has helped flag billions in risk to critical supply chains across the country, up to 6 months before they showed up in data. And at the moment, multiple US states are using Iceberg to monitor trillions in workforce exposure and infrastructure risks due to AI-driven displacement. Iceberg has been featured extensively in the press. CNBC did an entire segment on us, and we've been backed by leading institutions like JP Morgan and the Ballmer Group to take this national risk intelligence into an enterprise platform. We're now building Iceberg for the enterprise, and our first focus is to bring this to risk intelligence in mortgage and commercial loans, which represents a $30 billion opportunity. We already have a strong pipeline of institutional partners that are piloting the Iceberg platform. With $100,000 from the 100K, we can use this to convert our partnerships into pilots and our pilots into long-term enterprise revenue. Our long-term goal is to reimagine risk intelligence in the new economy, where societies of digital agents work together to preempt risks and disruptions to the human economy. Moody's built a $70 billion business pricing credit risk with historical data. Iceberg prices what comes next. Thank you.
Thank you so much. We'll take a momentary pause before we get to Q&A. We're going to put on a speaker so that you guys can hear each other well. If our AV guys can put on the speaker, that'd be great.
Okay. James, you good for a loud question?
Well, now they'll be able to hear us either way.
We can do AI, but we need AV.
Awesome, thanks.
Thanks, team.
I'm happy to jump in. What is the gold standard back test here?
So for each of the applications we deploy, we've done extensive backtesting a lot of things. For example, for all the labor systems that we've deployed in the country, which multiple states are using, we've backtested against last 20 years of BLS. So all these systems are rigorously backtested against last 20 years of data that the BLS produces. And we will also use it to run a lot of proprietary benchmarks against census surveys. So our backtest is can our systems essentially recreate the census for pennies on the dollar. So in a lot of papers we've published, which are in PNAS, Nature Medicine, a lot of top AI conferences, we've shown that these systems can actually model behavior patterns across actual census surveys that the US government does for a lot of millions of dollars. And we backtest against a lot of both census survey data, and then when we make it work for institutions, we also do backtests against a lot of proprietary signal that they are capturing. For example, especially focused on co-star signal in commercial real estate and things like that.
I'm being provocative. I wonder if your predictions are going to create those as realities. It's like an AI redlining.
I'd say that's a very interesting question. And I think it's slightly independent. So our systems are not really doing intervention. They're doing risk monitoring, which means that a lot of what the reality that's shaping up is how things are actually in motion. Our systems are not closing the feedback loop into doing stuff in the physical world, but in principle, we can do that. For example, like some of the other projects we've helped, like the USDA do, we help them sort of monitor and stop like disruptions such as bird flu outbreaks on the US food supply chain across the country. So the whole goal there was to orchestrate a reality where we can like stop disruptions on the supply chain, save revenue for farmers, make sure consumer prices go low. So in many cases, like creating reality is the capability that makes it more powerful.
Can you talk about who built the system and who are you planning to hire to continue to build?
So we started building it. So I mean, I built this over the last 5 years during my PhD at MIT. Ramesh and I were like the lead architects. We started off with like an open source community, so we've had a lot of active open source contributors, and like a lot of national labs, government institutions, organizations have contributed to it over the years. So that's the core of the platform we built in our lab. It's MIT-owned IP. We've published a lot of papers about it. And we're now starting to hire like our first set of engineers who are more focused on like infrastructure and DevOps and making sure like platform robustness works at scale. Because making our stuff work requires you to be really good at AI, but also really good at like running really large-scale infrastructure systems. So we're hiring more on the engineering side and definitely on the go-to-market side.
So you're hiring them now? You have like
The goal is to like start hiring over the next few months. We have like a pipeline of people who we've been cultivating through our like open source stuff.
Could you say one word around like some of the sort of newer generation competitors that are focused more on, you know, LLM simulation agent type things?
Yeah. So I mean, I'd say like, yeah, they're mostly, so we see it as being like two kinds of competitors we have. One is on the simulation side. So and I would say the other is on the scale side. So essentially, there are some of these simulation companies that have come up in the last few years. Like there's Aru, there's Simile, which came out of Stanford, there's Isara, which came out of Harvard. A lot of them are very focused on like modeling human personas. So they mostly work in systems that are like few thousand agents. The problems we care about are behavior plus second-order effects. We want to see like how behavior translates to supply chains or to real estate. So our systems are sort of at the intersection of competitors who do most of the LLM companies are very focused on few thousand agents. We scale to millions. And there's some competitors on the analytics side, which we feel are going to be like more important to think through.
Thank you so much. Up next, we have DesignFlow AI. DesignFlow AI is a design intelligence app embedded in CAD, giving engineers contextual design insights in real time. Please give me a round of applause for DesignFlow AI.
Good evening, everyone. We are the team of DesignFlow AI, building a company brain for engineering design. I am Hiro from MIT SDM and ESS. Before MIT, 10 years at Toyota in body design engineering, 14 patents, then Apple as a product designer. And every one of those years, I lived the problem we are solving today. My co-founder, Lowell, is deep in AI and ML at MIT. His thesis addresses the core differentiator of what we are building. When I was a mechanical engineer at Toyota, I designed the vehicle body structure. Single vehicle has up to 30,000 parts. Over 1,000 engineers to optimize one single vehicle. Their job is to design. However, half of their time is not design. It is email, searching wikis, hunting through shared drives, meetings to understand where the right of information lives. I lived this for 10 years. I had a difficult time looking for information I needed it to do my own engineering work at Toyota or Apple. Every part has a story. Why the material? Why the thickness? Why the radius? That story is scattered. Different locations, different format, different people. It is never connected to the part on your screen. Our vision is simple. Every engineering decision is informed by everything the organization knows. A company brain for engineering. Alive, searchable, tied to the geometry where decisions are actually made. We realized through our vision, $50 million in manpower savings alone per year per customer. On top of this, customers can save $30 million in engineering errors per project. We built engineering design intelligence. DesignFlow AI retrieves engineering knowledge from your sources, deliver instant feedback inside the CAD, and execute design changes without leaving the model. Our mode is engineering knowledge connected to CAD. Two knowledge layers, general engineering principles, and your company-specific lesson learned. the retrieval layer that uses them, and the CAD layer no computer has, geometry aware, tied to the cursor, look to the future the engineers designing right now. We have built 2 prototypes. The first retrieves engineering knowledge from your sources. It retrieves with evidence. This is very important. Engineers design systems that carry people's lives. They will never accept hallucination. The second sits in the CAD environment. It reads the geometry. The engineer dictates the change in a plain language. The model updates instantly. We are merging the two. Ask a question about the parts on your screen. Get the right answer in the context of engineering design. Make a decision only a human engineer can make. The market grows to $34 billion by year 34. Roughly 1 million design engineers in the industry. They are our customer. We enter through automotive, OEMs, Tier 1, Tier 2 suppliers, where my 10 years network and experience give us a direct access. We've completed more than 70 customer interviews, 2 prototypes, and product demo, and letters of intent from Rivian, Toyota, Tier 1 supplier. My network and industrial conferences open doors. Then we prove the LOIs there. Then pilot starts. Then prove the ROI. We scale team by team. We co-develop with customers. Our first paid pilot will run this summer. The economics get better at every step. We set our price 50% lower than existing CAD software. We are a complement, not a replacement. Pilot ACB 30K to enterprise ACB 480K. LTV to CAC ratio scales from 10x to 26x, driven by CAD workflow embedding and the bottom-up expansion. We aim for 50 million ARR by year 5. First pay pilot this summer, 4 million ARR by year 28, 95 enterprise customers year 31. I know exactly what this industry needs. I needed it myself. Lowell knows exactly how to build it. We are graduating this spring, full time on this from day 1. We have domain expertise. We have technology. We have letters of intent from companies. What we are missing is just funding. This 100K unlocks our first 3 pay pilot and pre-sale round. 40K for pilot technical integration and investor meetings. Engineers spend half of their day not engineering. We are giving it back to them. Thank you.
Could you help me imagine the migration process I'd have to go through if I started working with you?
Yes. So assuming you are one of the OEMs or Tier 1 supplier, so what you do first, awareness, starting awareness. So we are going to have interviews with them, asking what the pain point there. So then eventually we figure out the most pain point is information retrieval first. So then we are integrating our system into their system. Then eventually scaling from there, team tier and enterprise tier I showed the previous slide.
The big theme I'm seeing in the market right now is people trying to build tools that agents use versus humans use. Is there anything particular about this workflow that you think that humans should live in it for the next 10 years versus building for an agent-native workflow?
Yes, so essentially we are thinking about human in the loop is important part because essentially engineer have to make a decision to make a system that carry people's lives. So essentially the information retrieved, but human should be the one who make a decision.
Is your business model dependent on the clear ROI that you show?
Yes. So like ROI for customers, right?
Yes.
Yes. So we are thinking 3 KPIs here: non-value added work reduction, also usage frequency, and potentially like more than 50%, then NPS more than 40. So that is the 3 main KPIs we are pursuing through our pilot project.
If you were to sell an outcome here versus the seat, what is the outcome that the end user would buy?
Yes. So right now, engineers spend half of their day not engineering, like searching the information. Also, they want to design something. So with this product, engineer can quickly design something without searching the information. That is manual thing right now.
An end design out the end.
Yes, in the design, yes.
Is there, kind of echoing Parker's question, is there an outsourced function that you're trying to automate or provide value to, or is it just internal tools and internal workflows?
So right now it's all internal. Although to the point of Parker a while ago, the real moat here is building a specific knowledge graph. That's what we call it, and that allows in the future multi-hop reasoning and probably agentic workflows. And in that sense, we can expand from mere internal workflows, which we have right now, to probably external. Although, like what Hiro said, we're very wary of that for the moment because we want to give humans first piece of the pie because we don't want safety to be compromised.
You mentioned you build a novel way to pull context from a CAD system. Is that something you had to roll on your own? Is that a big piece of the IP here?
Yeah, so right now, most of the players are actually just doing textual. So what we have allows to incorporate the geometry into the knowledge graph. So that's part of the moat. So the construction of that, how do you construct that? And how do you incorporate the semantics of geometry into text?
Thank you so much.
Thank you. Let's now welcome Uplift Microhome. Uplift Microhome is bringing housing on demand. Please give me a round of applause for Uplift Microhome.
Every year, millions of Americans are displaced by natural disasters. If they're lucky, they crowd out of state with their friends and family. If they're not so lucky, they could end up in a homeless shelter. The thing is, though, disasters aren't just two-week problems. It takes months, years, to get back to what life was like before. Bottom line, we lack dignified and affordable housing after a disaster. 4 months later, FEMA housing arrives. Single-use trailers in a dirt lot hundreds of miles away. Why does this take so long? 3 reasons. 1, the products today require power and water utilities to be online, on-site. 2, they have extensive foundation preparation requirements. And 3, their transportation logistics are so costly, they will not pick them up, move them, and use them again, ever. And as a result, less than 1% of the survivors actually receive a physical home. The rest get a check and are told to just go figure it out. This isn't just our opinion, no. DHS audited FEMA, and they only had one recommendation in the report: provide a housing alternative that allows survivors to be close to home and is cost effective. And that, audience, is what we are building. A new world where housing can be on demand for anyone, anywhere, at any time.
And we're doing it with the Uplift Microhome. The Microhome is a highly engineered housing unit designed to address those 3 critical bottlenecks of current disaster housing. The Microhome is off-grid capable with an onboard battery and water reservoir, eliminating the requirement for power and water utility hookups. The Microhome has a self-leveling base, allowing it to be deployed on uneven terrain with minimal foundation preparation. And the Microhome is forklift deployable, dramatically simplifying delivery, installation, and deactivation to the point where you can economically recover, refurbish, and redeploy the unit. We actually built one. This isn't an idea, it's physical. NBC came to check it out to show the world what's inside.
All of this fits in 60 square feet. You've got a bed, a bathroom, a shower, hot water, a kitchen table, and it all runs on battery power. Once it lands, it levels itself. No foundation, no construction. The units are designed to fit 4 or 5 on a flatbed, then a forklift drops it where it's needed.
And now that we've actually built this, we're confident that we can manufacture and sell this product at a cost similar to that of the cheapest travel trailer while delivering housing in just hours rather than months. Our square footage is smaller, but we're designing for temporary transitional housing, not permanent. In fact, we expect the marginal cost of redeploying to a new disaster, even with today's diesel prices, to be greater than an order of magnitude less expensive than current solutions. And just this past week at the FEMA Review Council, Secretary of Homeland Security Mark Wayne Mueller called for a product exactly like ours. He said they're looking for something they can take from one disaster to another. This hasn't existed until we just built it.
Uplift Microhome will be a featured exhibitor at the largest disaster relief conference in the US. They let us in without even having delivered a product yet. And when I say tomorrow, I mean tomorrow, literally. I was in Florida this morning, and it is on the exhibit hall floor. And right after this competition, Trevor and I are taking a red eye to talk to the disaster relief managers and the people who write checks for temporary disaster housing. Now, I want to be clear on the business. We will engineer and manufacture this product in the United States, and we will sell it for profit in a market size that's already $20 billion alone just for temporary and disaster housing. Now, this is just the beginning. There are so many people that need better housing. It's not just disaster relief. Seasonal workers, construction like AI data centers, and of course, homelessness. Now, you might be saying, manufacturing's hard. We are the right team. I was at SpaceX for 5 years. I mass-produced the Starlink network. I've enabled anyone to have internet on Earth. Trevor spent 5 years at Tesla scaling vehicle electronics. We do mass production. So, let's end disaster homelessness. Thank you.
Great presentation. How do you guys know each other?
We both were accepted at MIT. I picked correctly. He picked Harvard.
We met at the admit day and got into a big argument about which school to choose, and we stayed in touch after that.
You talk about how long people are unhoused when there's a disaster and the cost of moving that stuff. Do you really think that these buildings, how long do you think someone would live in it, and do you really think that you could clean it up and refurbish it and actually use it later? Is it, yeah.
Well, we do think so. It hasn't been done before. That's why we built one. But we do expect, I mean, obviously I would invite you to come. It's in Florida now. But we do expect for people to live up to probably a year, sometimes longer, depending on who's living there. And yes, we can definitely design it to be refurbished. You do the right material selection on the inside, you can clean it very quickly, be very economical.
What's the biggest open question or point of confusion from your potential customers?
The people would often ask about water. That is most likely the question. It's the only consumable in this product. And when we do research on disaster supply chains, some states handle it better than others. But there is a precedent for delivering 300-gallon palletized water tanks. And we expect to be drawing that through an inline pump into our microhome.
Talk to us. One of the big features here seems like no plumbing. You know, everyone has to do number twos, which gets a little scary. So, like, how does the toilet work?
Yeah, the toilet's my least favorite, and we will engineer a better toilet, just to be clear. It's a two-part compostable, though, so it's actually quite manageable as is. It's just not up to, I think, our standards yet. But it separates both the pee and the poop, and you essentially can just manage it yourself. You take it out when you're done, throw it out. And it's pretty good. I just don't think a dignified toilet is one where you can kind of see what you did before. So we're going to engineer a new one. That would be our biggest engineering task for the next step.
Nice.
Yep.
Do you have any feedback from the government, which seems to be your biggest customer?
Yeah, the biggest conversation we've had right now is with a federal contractor named Copper River. They service several dozen companies that they sell into the government. It's a teaming operation where you work with them, and they're psyched. I mean, they're frequently seeing contracts that require off-grid housing that are not being fulfilled even years after they were first granted. And he's actually working directly, they're working directly with us to make sure that we're being exposed to these contracts.
After you are wildly successful in the US, when you think of other countries with disasters, are the component parts ones that are easily found and cheap there? Like, how would it work? How would a non-US expansion work?
Yeah, great question. The materials for this are going to be very similar to a car. We're going to manufacture it kind of like a car. Sheet metal forming, injection molding, casting. That's kind of going to be the long-term materials. Obviously, this one was wood, steel. It's different now for artisanal builds, but long-term, we see this coming off a line every couple seconds, just like a car, and those supply chains are around the world.
You could only pick one of the markets you showed. There was, homeless shelter, there's construction. What do you pick?
This company was started because of homelessness. It's just not the one you want to approach first. There's a trifecta of problems that we can talk for hours on for that. That whole stack of books in that picture there was to understand that market, and it's hard, but we're going to get there.
Thank you so much. And finally, last but not least, we have AutoLab. AutoLab is an autonomous AI and ML research platform that helps teams build better models faster. Please give me a round of applause for AutoLab.
Hi, we are building AutoLab, and we believe that the next generation of AI models won't be trained by humans. My name is Serge. I train vision language models at Harvard Medical School. This is Artem. He's at MIT, and previously he trained models at DeepMind and Meta Research. Our co-founder, Sean, was a forward-deployed engineer at Eli Lilly, working for Amazon and Uber, also training models. We've been through this process before, and we understand deeply the problem. Training models is an extremely slow and expensive process, and the main bottleneck are the humans themselves. You see, a single engineer can only do a few experiments at a time, change a few lines of code, maybe vary a few parameters. They cannot do hundreds of things in parallel. As a result, hundreds of GPUs, which are sitting there provisioned at MIT and Harvard right now, are actually being underutilized until it's paper season. The problem is even bigger at big enterprise companies, which are spending hundreds of thousands and sometimes millions of dollars per month provisioning these GPUs, which are sitting there idle, costing them a lot of money, and are not doing efficient work. People often ask us, well, why can't Cloud Code, Codex, or Cursor solve this problem? Well, you see, these are coding tools. Majority of the time, a machine learning engineer is sitting and looking at graphs. This is a very different, very nuanced process of how you're doing this task. And we are here to solve it.
So imagine you're a machine learning engineer at Pfizer, for instance. What you're doing is very important, because hopefully one day you will train a model that will design a drug that will help you save lives. But also it's very complicated. So the models that you're training is typically like thousands lines of code. And each model has this like tens of thousands different levers you can flip on or off. You can like adjust the sliders for the parameters. You can make it better or worse. And your goal as an ML engineer is basically to find a combination of these levers, that will give the best performance of the model. Your job is basically come in the morning, analyze lots of different logs that were produced by your training run, and try to make a guess what's the best set of parameters to train on. And so this is where AutoLab helps you. So whenever you come in the morning, instead of you going through like gigabytes and gigabytes of training logs, our agents do this. Previously, it's humanly impossible to analyze so much data. Now we can log much more, and our agents will analyze every single bit of these gigabytes of data that were saved over hundreds of runs you did the last months. And it will surface these very important insights, how each lever in your neural network correlates with the performance of the model. On top of this, your job is also very complicated, because if you're a very good ML engineer, you would be able to run maybe like 4 or 5 experiments in parallel. If you're even better than this, you probably can scale to 6, 10, or like 12 experiments in parallel. And then you will be orchestrating all these different ideas, trying to create a new set of them and scale again. But what AutoLab allows you to do is basically accumulate all the compute that you have in your enterprise, even like the old A6000s that everyone forgot and no one wants to train on them, and the new H200s that everyone wants to train on every single time. So AutoLab allows you to aggregate all of them, and we have this very important infrastructure layer that helps our agents to synchronize across different compute nodes and make sure that every single GPU spends every second trying to produce a best model possible. We are lucky to be running one of the biggest hacker communities here. It's called Sunday. And the reason why it's called Sunday is because we are meeting every single weekend, and we build for the entire day of Sunday. And so since we started working on AutoLab research, we basically adopted this weekly cycle of improvement. Every single weekend, we will bring a new version of AutoLab to our dear community, and we will get feedback from 50 to maybe 100 people who are doing different types of optimization, from CUDA kernels to transistor optimization for circuits or training LLMs. And we will try to get this very valuable feedback because our goal is to make AutoLab as addictive as Cloud Code for coders, but for researchers. We also collaborate with 3 different design partners, starting from startups on very early stage with one ML engineer, where we help them to be more efficient, and with bigger startups who train big foundational models, and it takes them hundreds of thousands of dollars to train a single model, where we help engineers to save money and be more efficient.
Training models is a huge market. Our go-to-market strategy is very simple and proven by companies such as Weights & Biases and Hugging Face. We go to top research labs at MIT, Harvard, and beyond, and we offer this service highly subsidized or free to researchers to learn from them. We iterate on this, and we take our learnings to industry, where we charge $200 per month per orchestrator to these companies. In addition, we can arbitrage between the shared compute that these companies can be renting from us. We believe in a new paradigm of doing science, where a single researcher has access to an autonomous lab that runs hundreds of experiments at any given time, utilizing all of your GPU compute and helping you to accelerate science faster. Thank you.
So I was an investor in Weights & Biases, so I have lots of opinions and happy to chat more about it later. But obviously the market is super concentrated among very big people with lots of opinions who kind of want to do things themselves now. Like, how do you think about how the market evolves over time?
Yeah, so I think that's very true for LLMs specifically, but there's this huge long tail of models being trained in like biopharma, finance. So yesterday we actually spoke to a biopharma startup doing drug discovery, and what they told us directly is, hey, we're building some of these tools internally, but this isn't what we want to focus on. We want to be the ones training models, and they're happy to take us on as partners or would buy our software if we can enable them to focus our time on that. So we think there's a huge long tail of that market.
A context question. So do you guys want to optimize the serving itself or no?
So for now, we focus mostly on optimization. So we are not dealing with inference or scaling. But the way how we think about this, and that's why probably we are not worried too much about competition. It's going to be a very crowded space. But we believe that there is so much value to be created because there are so many different hard problems you can focus on and build the product in the vertical. So we can eventually, if we see that the horizontal scaling doesn't work, we can pivot to building a vertical for inference optimization, right? In this case, we'll be helping clients to optimize the mapping of LLMs across their compute, for instance. We believe there is a new paradigm being created in how people approach any kind of optimization, not only training, but any NP-hard problems or any type of simulation optimization. And we believe there is a lot of value to be able to generate there. But for now, we want to focus on training specifically.
Got it.
I mean, there are a whole set of those guys who are doing sort of more naive, earlier hyperparameter sweep type things, right? And then a bunch of them basically got quickly commoditized. And so how do you think about that as a potential danger point for you?
That's a very good question, right? So if you've been following the ML space, you probably heard about AutoML, right? Which is this very complicated grid search on the hyperparameters. You might have heard about AlphaEvolve, very wonderful work, right? About evolutionary algorithms on program synthesis. But we believe that right now is the fundamental shift, and the difference is kind of people were trying to do code completion pre-LLM, and now doing Cloud Code. This is the amount of difference we see. Agents are capable to improve algorithms, evolutionary algorithms on program synthesis, or any type of optimization so much more efficiently just because of how general they are and how much data they've seen. So that's why we believe that AutoML didn't really make it to the market, but with the current scale and the capabilities of LLMs, this is what was missing. And we believe the fundamental shift is coming there.
What is the grand vision here? What is the 10 billion ARR path.
So we think it's shifting the entire paradigm. The way that we work with AI today is we get to work at 9 a.m., 10 a.m., whenever you get to work, we switch on Claude Code and we let Claude Code augment our thinking. We want to live in a world where you get to work at 9 a.m. and AutoLab has already produced a report for you for hundreds of different things that it has done. So while you were sleeping out, socializing with your friends, it was doing all the work, and you, the human who really knows the nuances of your industry and knows what are the tips and tricks of high-level reasoning, is able to then drive it to do more insights.
All right, so this year, that brings us to the end of all of our competitors. So let's have another huge round of applause for all the pitches that we heard tonight. And let's also continue the round of applause for the amazing questions that we had from our judges as well. Amazing. Now this year, we are so proud to introduce that the MIT 100K Entrepreneurship Competition has actually begun its expansion globally, and we launched our first expansion in Portugal this year. Building on that momentum, we are also thrilled to officially announce that next year, the MIT 100K competition is expanding into the ASEAN region, starting with Vietnam. But tonight, we are incredibly thrilled and very honored to be bringing the first ever winners of the MIT 100K Portugal onto the stage tonight. So I'm very proud to introduce the MIT Portugal winning team, FlashGuard.
Hi. So good afternoon, everyone. My name is Gonçalo Ribeiro, and I'm here today to talk about FlashGuard, a new device to make cancer treatment safer and more effective. So cancer is one of the greatest challenges of medicine at the moment, and radiotherapy plays a key role in treating this disease, as we use it in 50% of all cancer treatments. However, the current treatment that we use, conventional radiotherapy, comes at a cost. Several sessions for the patients, and they often experience side effects. And this is when researchers appeared and proposed a new method to deliver radiation. And we have concluded that when we deliver the same amount of radiation, just 1,000 times faster, we can spare healthy tissue. And with this, as we can see in the right figure, the pig skin irradiated exactly with the same amount of radiation in the flash mode. The conventional radiotherapy exhibits lesions, whereas the flash, the skin is preserved. In addition to this, the comparison between flash and radiotherapy is not only limited to the side effects. We also can compress the treatment of 20 to 30 sessions into a single one. And flash is expected to be used in every radiotherapy treatment in the future. However, can flash reach the clinic? And that answer is yes, but we are lacking technological advances, and one of them is the development of detectors. We need to measure with unprecedented temporal resolution this kind of beams. And for this, we have assembled a team of 5 3 students and 2 professors with large expertise in particle physics detectors. And we are also backed by an advisor in the USA and a startup founder in Portugal and also an advisor in CERN. But the purpose of our solution is to enable this with particle physics knowledge. We are using a patent-pending technology, and it is designed to replace every monitor chamber in radiotherapy accelerators, which play the role of ensuring patient safety during treatment, and they are in every conventional radiotherapy machine. We are designing a device that can be used both in flash and in the conventional treatments as well. Our competitive advantage is summarized in here. We compare the standard one that is used in every radiotherapy machine against the 5 criteria needed for a flash device. And you can see that our device is the only one that can fulfill all 5 requirements. Our IP is our main strategy. We are IP-driven, and we have submitted already several patents covering foundational concepts. And in the future, we aim to continue developing our business by licensing these to to leading experts, to leading manufacturers in the field, and then we continue to develop, as our vision is, to build a future of radiotherapy devices with IP-driven business. Our team has already accomplished a lot in the commercial side, not only scientific background, but also entrepreneurial side. And we already started testing in Lisbon. We are hoping to have in the next month a flash test performed in Lisbon as well. And in the future, we aim to continue developing this business with IP. We are building the future of radiotherapy one design at a time. I would like to thank everyone being here. And I would like to invite my team coming here because they also deserve quite an acknowledgement. So thank you very much, everyone. Can you... Yeah. Thank you.
Questions? No questions. No questions.
No questions. Oh, you can ask later.
Deal.
Thank you.
Thank you so much. We are so excited about this global expansion and so excited to see what happens next year. Once again, we have now completed all the presentations that you will be hearing tonight. Oh, hold on a second. So now, voting for the Audience Choice Award is officially open. You will have until 7:50 to vote. If you are in person with us, please scan the QR code that you received once you walked into the auditorium. There's a unique voting code on each of these cards that you will use to place all of your votes. We will also call you back once the voting is in, and we will announce all of our winners. Thank you so much, and we look forward to the announcement. And we'll leave this on for you to scan.
Hi, everyone. If you received a card with the QR code and the QR code is not working, please scan the QR code that is displayed here. Thank you for the Audience Choice Award. Hello, everybody. Please make your way back inside for the announcement of the winners. Okay. Yes. Yes. Thank you so much. We will be beginning shortly. Resuming shortly. Are we good to go?
Yes, I can.
Okay. Welcome back, everyone. We are excited to bring our program tonight to its exciting conclusion. Tonight we'll be presenting a few prizes. First, we'll be doing the audience choice winner, which you have just selected, and it will receive $5,000. The third place will receive $5,000 as well. The David T. Morgenthaler Founders Prize winner will receive $50K, and then the grand prize winner will receive $100K. So, yes, round of applause for all of our competitors. Now, to announce our winners, so we're going to do a round of applause for our Audience Choice Award winner, who will be receiving $5,000, is Pixology. Yes, go on stage. Please go in the middle so we can take the picture. Picture.
Amazing. So for our third runner-up, our third place winner is, drum roll please, Iceberg Systems. Congrats, guys. For our second place, drum roll please, we have Mohan. Congratulations.
All right, is everybody ready? Now, I have the extreme honor and privilege of announcing the first place prize winner, the winner of $100,000 and the MIT 100K Entrepreneurship Competition. Our winner is, drum roll, Uplift Micro Home. Congratulations. Well, congratulations. Congratulations. All right, so that concludes the MIT 100K Entrepreneurship Competition. Thank you so much for joining us. We would love to give a huge round of applause to our, last bits of announcements. We would love to give a huge round of applause to our judges, our sponsors, MIT AV and Video, and most importantly, all of our competitors tonight. On behalf of the entire MIT 100K organizing team, thank you so much for joining us here tonight, and we look forward to seeing you next year. If the MIT team can come on.
We also like to give a huge round of applause to our MIT 100K team. Without them, we couldn't do it.
Can they all join us on stage, please?
Yes, because the MIT 100K leadership team, please join us on stage.
Get a huge round of applause for our team.
Adam! Woo! We might want to text as well. Can anyone text also?
Also, if everyone would please, 1 second please, I want to give a huge thank you to our 3 managing directors of this year's 100K competition. Jayshree, Taylor, and Celine have put in hours and hours of work for this. It has been an awesome event and a pleasure to work with you all, so thank you on behalf of the entire 100K team.
Yes, all together. We need to.
Okay, can the organizing team come on stage for a picture?
Organizing team on stage, please. Thank you.
Where's the photographer? Where is the photographer? Oh my God.
Who's in the audience?
The photographer. Oh, he's there.
Yes,
Okay,
he's
cool,
in
cool,
front
cool,
of us.
cool. Okay, cool. All right. I want some of the judges before the
Yes,
Can we also get the judges?
Judges, please come on stage as well.
Also, take a picture with you guys. All the judges, yeah. Okay, I think we lost. We should, but they're gonna
A lot of pictures, we might have trouble.
Yeah, exactly. All right. Oh, where's our other?
Who's my? I'm in front of you. Why am I in front
Is your
of
mic
you?
on? Mine is not.
Yes, it's on.
Can you call the judges?
Yes. Judges!
Oh. Okay.
Where are the judges?
Okay, judges, if you are still here, please make your way to the stage so we can take a photo with all of you. Yes! Wait,
Amazing. And then we have.
I think you can stand.
Okay.
Yeah,
I think we can stand.
I was like, I'm wearing
I think you 3 should be in the middle.
Yes, the judges should be in the middle.
Like sit down?
No, like just be in the
not
middle.
sit
We'll
down.
rearrange.
Yes, we'll rearrange
Okay.
around the 3 of you.
Come close.
It's hard because people are behind us. Yeah. Thank you. Thank you. If any